Good afternoon, all. So, on behalf of the Department of Electronics and Communication Engineering, I welcome you all to this workshop on documentation using Latex. So first, I'll just want to give you a brief introduction that what is the significance of this workshop, why we have to know this latex. So this latex is a markup language. So once we learn this, it will save a lot of time because it automatically generates a table of contents, bibliography, and other various elements like title, author, headings. So all these things can be easily organized, and also we no need to worry about the typesetting. So and also it is helpful in rendering high quality typesetting, and for it is an existing approach for creating a documents nowadays, and which gives you the extremely fine grained control of document layout, and it provides you very high quality and extremely customizable and also stable, and no need to worry about the safety of our document as well, because there is no virus threat if we are creating our documents with the help of latex. So I request everyone to take advantage of this opportunity and learn how to work with latex. And I also welcome Dr. Chandrasekhar, who will be presenting about this how to do the documentation using latex. So thank you for all your interest in this, and over to you, Chandra sir.
Good evening, good afternoon, everyone. I hope I'm audible to all of you. Yes. So, is the volume, everything is clear?
Yes, sir.
All right. Uh, this will be, is the screen visible to everyone?
Yes, sir.
All right. So, I think Sheikh Suleiman can take a lead from the audience to respond to my queries. So, good afternoon,
Sure, sir.
everyone, and welcome to the workshop on documentation using LaTeX. And I've seen that there are participants from different departments like mechanical and even from the computer science also. So, and in view of participants' interest, we actually thought it would be great if we can handle a one-day workshop. If uh, if this goes well, then probably we can extend this in the next month to have a more or deeper understanding of LaTeX, not just limited to report making, but we can also see how can we prepare slides and resumes and other textbook kind of things. Okay. So, as briefly mentioned about the LaTeX importance by Devi Kaman, that LaTeX is one of the beautiful typesetting environment tool which is available to all the scientific and technological community people, and this is especially used for preparing reports and uh, textbooks and presentations specifically to people who are involved in the scientific and technological research. Okay, so the main advantage of using LaTeX is that you do not have to worry about the typesetting at all. So being a researcher, most of our time, if we keep on setting the margins, the fonts, and etc., we will go off the track from the content. So keeping that in mind, the LaTeX community has come up with this tool called LaTeX, which where the main attention will be only on the content preparation, not the typesetting data. Okay. So with this, we will start our presentation. This will be the outline of my presentation. We will start with the brief introduction to LaTeX, and we will compare it with what LaTeX is not. Okay, like everyone knows what MS Word is, but do you really know what are the disadvantages of MS Word? So likewise, we will also see what LaTeX is and what LaTeX is not. Then we will briefly see how to install LaTeX. This second point I will not spend much time because I've already sent you a document which mentions about the installation of LaTeX on different operating systems like Windows, Linux, and Mac OS. But nevertheless, if you do not have a ready software available onto your system, we have the alternate option to do it online. There is an online in-browser LaTeX tool that's called Overleaf. You can go to the website and type in Overleaf and then create a project with your valid username and ID, and you'll be good to go. Then after that, we will start we get started with LaTeX, and there is a second document also which is shared among the participants, which mentions briefly about all the major things which we deal in report making. For example, the title, the sections, the subsections, creating a table, adding a figure, and labeling all the figures in the tables, etc. Bullet points, numbering points, and all that. So what plan which I have made is that from that document, as and when I keep on explaining the things, you just copy paste the code, the specific code which is there in the second document, and you can paste it in your LaTeX editor and then compile it just to see the runtime output. Okay, so in that we will touch upon most of the things like how to start the first program or the first code which we write it on the LaTeX. Just like you have C and C++ hello world program, here also we will see we will try to write a hello world program and see whether all the environment setup is clear or not. Then we will see what is preamble. Then we start to see how to write different paragraphs. We will see how to bold, italic, and underline the text. We will see how to add the figures, the caption, the label, and the references. We will see how to create the list, whether it's a bullet point listing or number listing. We will see those different types. This is one very interesting thing, adding maths to the LaTeX, because all the integration, differentiation concept, the the symbols are not so easy when you are doing it in the MS Word. So we will see how effectively or how easily we can do it in LaTeX. Then we will see how to create different chapters and sections in the report. Then creating a table, adding a table of content, and adding the bibliography. Once we learn all of this, we will see few examples to create a simple report. Just like I think most of you are from Dayanand Sagar University, so probably I will show you one sample report of how to create a project report using the LaTeX. Then we will see one of the again example of creating a IEEE conference paper, uh, and another example of having a Springer journal paper. So what I'll do is whatever content I prepare for the report, the same thing I'll try to export it to the conference paper as well as journal paper without worrying about the typesetting. Okay, and then few references where you can read more about it and learn more. So introduction to LaTeX. Bear with me. This first point we will learn a little bit about LaTeX because there are few who are newcomers to this. So I want to give them a little bit of introduction about LaTeX. So and after that we will get on to the real part. So LaTeX is generally pronounced as LaTeX. It is not latex. Okay. So most of the people pronounce it as latex, but it is not latex. It is LaTeX. Okay, and LaTeX is basically a document preparation system for high quality typesetting, and the major advantage is that the LaTeX can be used from a medium to a large a technical or a scientific document. If this is just a one-page document, then I would recommend you don't go for LaTeX. If you are new to this, you can preferably use MS Word. But then if you are preparing a report which is like 10 pages, 20 pages, or a MTech thesis or PhD thesis which goes to 100, 200, 300 pages, then LaTeX is very much useful. And then LaTeX helps author to get rid of the get on with the writing documents and leave the worries about the document design. So you really don't worry about the type settings, all the font settings and the bullet points and all that. So you just worry about writing the contents. That will be the whole uh, concentration or your interest will be towards. So LaTeX is based on Donald E. Nuts. So this is a typesetting language which is being set by this person, and this was first developed in the year 1985 by Leslie Lamport. Okay. Now the project which was earlier launched, now it is being handled and maintained by a LaTeX 3 project. So what LaTeX is not? So so LaTeX is not a word processor. Okay, just like you have MS Word, which means to say that whatever you type, you actually see the content. That is what is called as what you see is what you get. Okay, because in the word processing, as soon as you press a key A, you get to see A on the word processing document. But LaTeX is not what you see, what you get. Okay, this is basically, in fact, what you see is what you mean. So this G gets replaced by M. So we will see how it is. It will be more clear as when we go to the next thing. So, so this is one pictorial screenshot of a content which is written in the Word and the content which is written in the LaTeX. The above picture you can see here is that there is a content which is written in the Word, and there is a header which is bold enough, and it starts from the first line without any indentation and then go on till the last part. Okay, so as soon as you key in the characters, you start to see all those keyed characters onto your document. But coming to this picture which is shown below, this is which is being generated by the LaTeX. You see, do not worry about these blue and the red part. I will explain you it little later. But then you see, you have this paragraph which is unhighlighted. That unhighlighted part is shown in the output document. But then the highlighted part which is just written in the uh, text file, which is not really appearing in the output. So this means to say that, sorry, this means to say that whatever is there, you are not really actually seeing it. So it is not what you see is what you get. Okay, this is basically what you see is what you mean. So only when you compile this particular file, all the changes which you have made here will be reflected in the output. Okay, so why learn LaTeX? This is again important. Uh, it's good that most of you have joined today to learn LaTeX. I'm sure many of the finalist students might be missing this because of the carelessness, but nevertheless, those who are here, it's a good point, a learning point for you. So LaTeX is used all over the world for scientific documents, books, and many other forms of document publishing. Okay, and it creates a beautifully typeset document. So this is one of the advantage that being a student or a researcher, you don't have to break your head in typesetting the document, and it allows to quickly tackle any complicated part of typesetting. For example, if you are creating a word with a right and the left margin of 1 centimeter, top and the bottom margin of again 1 centimeter, if you want to change those margin values to certain, let's say 0.5 value, it is like a cumbersome. You have to go to certain tab, do a drop down, find that particular item, how to change the top, left, bottom and top margin. But then with LaTeX, just with a one single command, just by changing the value of 1 to 1.5, 0.5, you are done. Okay, so it is as quickly as possible. So and it is easy for inputting all the mathematics. It helps in creating the table of contents, references, and creating bibliography. Bibliography is basically the last part of your report, which is the reference part. And why learn LaTeX is, this is again one more important thing, is that it separates the content from the style. That is the reason why I will be able to code all my report content into a conference paper or a conference paper content into a journal paper. So it basically separates both the content as well as a style. So you just have to take the content and put it in any style which you want. Okay, and once the content is written, we can change its appearance with each. Okay, so this is a comparison of writing a LaTeX document or a MS Word document. On the y-axis is the effort and the time consumption, and on the x-axis it's the document complexity and size. Now you see, that is what I have told initially. If you are dealing with a one-page or a two-page document, you better start off with MS Word, because the complexity is very low here, but then the amount of effort which you have to put in is also low. But if On the counterpart, if you use a LaTeX for 1 or 2 page of document, you need to put in more efforts as compared to MS Word. But you see the graph, as the x-axis keeps on increasing, which means as the complexity or the size of the document keeps on increasing, the MS Word requires more and more and more efforts. But if you look at the LaTeX graph, which is the bold graph, the amount of efforts and the time consumption is very much lesser. Okay, probably this difference is too heavy if you are dealing with 100 or 200 pages. Okay, so that is all about introduction. Now, how to install LaTeX? Again, I won't spend much time on this. Now, this is a free software under the term of LaTeX PPL, that's Project Public License, and LaTeX is distributed through CTAN servers. There are a few packages which we try to install when you are trying to do some extra activity in your LaTeX code. That time you need to install some packages. So all of this LaTeX distribution is available in CTAN servers. And LaTeX is not a standalone typesetting program in itself, but it is basically a software that runs on the LaTeX or the tech typesetting which is being developed by Donald Knuts. So these are different operating systems on which you can work on using LaTeX. The most preferable, which most of the researcher or scientific or technological people use, is Linux. Even Mac OS, most of the people use, and Window also is preferably used by most of the students, those who are not familiar with either Linux or the Mac OS command prompts. And if nothing of this is okay with you, you can go ahead and work on LaTeX using the online version. Okay. Now I have listed out few here. Mac Tech distribution is for Mac OS, MicTech and TechLive, and ProTech is, these distributions are available for Windows, and TechLive distribution, uh, Linux Tech. There are so many other distributions which are freely available for the Linux version also. So it is up to you which platform you want to use and start working on tech. Okay, so this is one very popular MicTech tool which is available on all Windows, Mac, and Linux. Okay, so you can preferably download this MicTech software and you can install based on your operating system. Download the file and install it. Okay, all right. So that was all basics of introduction to LaTeX and how to install it. So let's get started with LaTeX code. Now, now in this particular thing, you may have to continuously refer the document to which I have sent out. So we will start with saying that how, so this is just a sample of how LaTeX looks. Okay. So the tool which I have used is on the Linux operating system, and the LaTeX tool which I have used is Text Studio. So this is the GUI of a Text Studio on LaTeX operating system. Now this is, now do not take this LaTeX as a software coding. It, at the first view, it appears to be like a code, but it is not really a code. It's kind of an HTML language which you must have studied in your 11th, 12th to create the web pages. It's just like that. Okay, so this is a LaTeX file. One point to remember is that the extension of the tex files will always be .eex. The extension of all the tex files has to be .eex. Now this is a LaTeX file which begins with something called as /document class. So here all the environments or the packages which I use in my file, they will all start with /. So this is first line of the text file, /document class. In the curly brackets, there is something called as article. Now this first line indicates that whatever is being done in this file, that will form a article kind of a type representation. Okay, and your second line is /begin document. That means, okay, this is again very much important. Without this, your file will never ever compile. So first line is compulsory, second line is compulsory, and the last line is compulsory. Other than these three lines, if you do not have these three lines, then your text file will never ever compile. Okay. Okay, so everything revolves around these three lines. Now the content which is written inside a slash begin document and the slash end document is what is getting compiled and shown into your output file. And the beauty of the LaTeX is that when you compile your document, the output which is generated is always in the PDF form. So it is easy for us to share and download and take a printout and whatnot. Okay, so is this fine till this point? Everyone is following?
Yes.
All right. So, so just by looking at the template, it looks very good. You see that there is a title which is at the center. There is an indentation for the first paragraph, and you see that the texts are not either left aligned or right aligned. They are properly justified. Justify alignment is there. There is no here and there alignment. So this is what is the main purpose of that. That the LaTeX does not give you a worry on typesetting. You just have to concentrate on the contents of the document. Okay. Now this is a typical flow chart of the LaTeX, how it basically compiles inside. So you don't have to really worry about it, but then you should know what happens behind the scene. Okay. So this is one of the sources where you are creating your text file. It will be either text or LaTeX, any of the sources which are available on any of the operating system. Okay. Now, once you run this particular .text file, it first converts it into a DVI format. Now, DVI is one more format by which you can either increase the resolution, decrease the resolution of pictures, and so on. Okay, so do not worry about this for the time being, but just remember this is one format in which when you perform a text operation on the file, it gets first converted to DVI format. Then DVI to PS command is the one which helps you convert from DVI to PS format, and then from PS to PDF there is a command called PS to PDF. So this command will basically convert your PS file to PDF file, and this is what is your final document which is ready to use. Okay, now there is a other way around also. If you don't want to go through this loop, you have a direct option to convert your text file into a PDF file directly without being involved in converting it to the intermediate files or the formats. Okay, so so this will be the first kind of a hello world program for LaTeX. I request all of you to take to open your second document, and there is a portion called a hello world program. Try to copy this and paste it in your tech environment and run that particular file and see what output you get. Are you all with me? So try to open the document which I have sent. It is preferably this document which I'm talking about, the LaTeX documentation, this thing. You try to copy this code, and paste it in your tech environment. Let me know if you're able to do it, or let me also know if you're not able to do it. You can use the chat section to inform me. Is it working? Are you guys just listening or doing it side by side? Okay, one point, if you guys do not have LaTeX installed, you can definitely go to the overleaf. You can go to overleaf, type in Google, click on the first link. It takes you to the overleaf project page. You create your account there and then click on a new project. Okay. Now once you have created the new project, it looks something like this. So these are all my projects. I click on the project and it opens up in the in-browser LaTeX. So any difficulty in running the code? Anyone? Or anyone who has not got it?
We got the expected result.
Okay. So yes, so this is the basic Hello World program which runs through all those commands which I have mentioned previously and gives you the output. And for your information, this output is nothing but a document which is a PDF document. Okay. And let's try to break up this code and see what all this code contains. As I mentioned earlier, that you need to have these three lines compulsorily in your LaTeX code. So the first line is document class, and this is the type of the class. The article is nothing but the type of the class. If you want to deal with a different type of the class, for example, book, you replace this article with book. If you want to create an article which is having a different format, you replace this article with a report. If you want to write some journal paper or conference paper, they will provide some class file. You replace this article with that respective class file. Okay. So the first line should always be a document slash document class. Now after this, there is second line called slash begin document, and the last line is slash end document. So this is what is called as the body of uh, the text file. Okay, and all the content which needs to appear in your output file has to be within the body of the text file. Okay, now once you have written this, you just have to compile the document which generates the PDF file. So is this clear to you? So here document class article is basically the class which controls the formatting of your complete report, be it the margin, be it the font, be it the size of the text, and whatsoever. Okay, so this is what is important. You need to know what kind of class you should use. Now for all the general report making, people use article or report. But then if you are writing a textbook or let's say a thesis, then you need to use something else here. Okay, I think report will also work for thesis. All right, let's try to look at the other example. Now the left, okay, for your information, the left side is the code which you can copy paste from the documents to, and the right side is what you see the output for the corresponding code. Okay, so here the next part which you will see is the preamble part. Now preamble is the part, I don't know if I can take the marker here. No, I think it's not available in this. So the preamble part basically exists between your slash document class and slash begin document. So these are the things which are called as preamble. Now preamble are basically to include certain packages which are required for creating a document, or few title headings, or the author names, or the date of the project creation, and so on. Now looking closely at this, the preamble part consisting of something called as slash use package. Okay, so whenever you want to do something extra other than the text, you need to use the package. And to include the package, this is a command slash use package. And in the curly brackets, you need to include the name of the package. Now this is like input enc. Now this input encoder is basically used to include all the encodings or the ASCII characters which are available in English. Okay. Now the second preamble which you see is a title. Now for your information, this is a case sensitive. A capital TITEL is different from small TITLE. Okay, so capital title or the small title command, both are different. So here all the commands are basically in a lower case. So here the second preamble is slash title. In the curly brackets, you give the appropriate title of the document. Now in this context, You can use the small content or the uppercase content, it's up to you. Next is, if you want to add the author, you say slash author, and then in curly brackets, you add the author name. Then if you want to add the date, you say slash date, and in curly brackets, you can write today's date. Or if you want to do a system generated date, you can say slash today. So here slash today is again one more internal LaTeX command. Okay, so you see this document was generated on October 5th. So that day when I have run this code, it was October 5. Sorry, October 5 it was. So that's why it is showing October 5. And rest of the things remain the same, which is the body of the LaTeX. Is this clear? Now, this preamble is basically used to define the document, the language, and the packages and other elements. Okay, so if you want to include the title to any report or use any packages or do some kind of a changes in your overall typesetting, you can all do it in the preamble section, not in the body section. Okay, all right. Have you copy pasted this and tried onto your LaTeX tool? You can go back again to your document. There is a second part called adding the preamble to the program. You just copy paste this portion and then run it. Okay, so you will be able to see the output. Okay, next is starting a paragraph. Now this is very common in any report forming. Like you basically write several paragraphs with certain indentation to every paragraphs. Okay. Now when you're okay, now the left picture shows only the body content, which is written inside slash begin document and slash end document. And the way you create a new paragraph is by typing a double backslash at the end of the paragraph. You look here in the picture here that I have written first paragraph and did double slash here, and then I write the next paragraph. Okay, now this probably goes to the next paragraph and starts writing this content. Okay, even if you do not want to write this double backslash, you can preferably just hit carriage written or the enter key 2 times, so that you basically have a one line spacing between the first paragraph and the second paragraph. In that case also, you are effectively creating a new paragraph. Okay. One good thing is that if I have multiple spaces between two characters, it ignores it, which means to say that let's say this is the first word this and the second word is. Now in between these two words I have just one space, and that is what is being reflected in the output. If I have 10, 20 or 100 spaces between these two words, those all spaces will be replaced by just a single space in the PDF file. Okay, so spaces does not matter. That is the reason why to create a second paragraph you need to hit 2 times enter. So enter is not considered as a space. That's a special character for the text file. Again, to have to view this output, you can okay, I think it's not there. You can randomly type in some text and check out what will be the output. Okay, going to the next slide. How do you create a bold, italic and the underlined text? Again, there is a command to use for bolding your text, for making the text italic and underlying the text. Okay, so the bold can be done by using the command slash text bf. Bf is nothing but bold font. Okay, now similarly for italic, it is a backslash text it italic, and whatever content you want to write, you write it inside the curly brackets. Similarly for underlining, slash underline inside the curly bracket, enter your text. Okay, now looking at the code here, this is again a body part of the text file, slash begin document slash end document. Now you see how this particular text file is getting converted into a properly manageable automatic typeset document. Now this is here, it reflects in the file, and then I have written here /techbf, and inside the bracket I have written some text. Now you see in the output it automatically gets bold. Okay, and you see a double slash, that means it goes to the next line. Now after the and, it starts the next line. Now in the next line I have slash text it, that means this is a command to italic the text, and between the curly brackets whatever text you have, that's gets italic into your output file. I hope you can notice this. Similarly here, comma and double backslash, then it takes it to the next line, and here again one more command called slash underline, then you have some text. You see this text is getting underlined. So these are the three different commonly used formatting in your report making, that is bold, italic and underline. Okay, this is again given in the document 2. Oh yes, I think, yeah. So this third part we have missed. I will tell you what is the third part. So fourth part, you can possibly copy this and check out what will be the output. The fifth part is nothing but bold, italic, underline. You can copy paste this thing and then paste it in your tech environment and check the output. Okay. Now remember here, this is something different than the what I have shown in this slide. There is no paragraph change by using double backslash. This is just a complete sentence. Okay, that is like a complete sentence for you. Is this all clear?
Yes, sir.
Okay, moving on. One of the very useful command in tech is, or for any report making, is to add figures, and Latex does it very in a very easy fashion. Okay, now there are few things. It initially might seem little complicated because you need to add in so many commands to execute to display the figure in the PDF file, but then nevertheless, once you get used to it, it will be very easy. Now, to add a figure, there are a few things which you have to remember. First thing is that you need a package, because figure is not like a normal text, so you cannot just keep writing contents without any supporting packages. Now these packages are something like the header file in your C programming. If you want to use printf scanf, you need to have a stdio.h file, right? Just like that, these packages have certain commands inside that which can be used to serve the purpose. So to add the figure, the package which I need is called graphics, graphics. Okay. Now you can see the way in which I have included this package. As I've mentioned in the earlier slide, that the packages are installed in the preamble section. So after the document class and before /begin document, this portion is nothing but your preamble section. So in the preamble section, you use slash, use package, curly brackets, inside curly brackets, graphics. So this automatically includes a graphics package, and all the commands which are used for including the image in your report is available in this package. Okay. Now, next thing is you need to create a folder in your existing working folder where you have kept all your images, right? So how do you actually create a folder? You can just do it in a random, normal, conventional way, like creating a new folder. And you need to add the path of that particular folder where you have kept all the images. Now to include the path of the folder where all the images are kept, the second, this particular command is used, /graphics path. This is very simple to remember, right? These are all like an English word. So this is /graphics path, and the format is you need to start with double curly brackets, end with double curly brackets, preferably a space between them, and then inside that, just the way you write any folder name, this dot is nothing but the current working folder, and inside the current working folder you have a folder called fig underscore sample. So just to show you, okay, you see this is my, are you able to see my screen, right? Yeah. So this is my text file where I have my representation, sorry, the presentation, and this is the PDF file which is running. And for this text file, whichever figures I want to use in this file, they are all in this folder. So I've created a folder called figure underscore tutorial, and these are my images. You see all of them are either PNGs or JPGs. Okay, so these are my images. So preferably I need to give the location of this particular folder to my text file. And how do you do this? You do this by using a slash graph, a graphics path. Okay, now these two are done. This is the preamble section which is done. Now how do you include the figure is by using a command called environment called FIGUR figure. Okay, when you say a environment, it always starts with slash begin and ends with slash end. And when I say command, it does not have slash begin and slash end prefixes. Okay, so this figure FIGUR is called as environment. Now between these begin and slash end figure environment, you see there is one important command which is used to include the figure called slash include graphics. Okay, now slash include graphics, at the curly brackets I have the name of, sorry, I have the name of the image. Now the name of the image is the name of the image which you want to display in the report. Now this is a corona image, so the name of the file is corona. Now one good part here is you don't really have to mention the extension .png or .jpg. It automatically by default take the respective file name. Okay, but in case if you have two different or three different files with the same name but with a different extension, then you need to worry, and then that time you have to give the extension of the file name also. Okay, now this is done. Now you see inside this square bracket, now whatever contents you write in the square bracket are always optional. It is not compulsory. The content inside the curly brackets are compulsory, but inside the square bracket they are optional. Now what happens if the size of the corona image is almost like 1000 resolution by 2000 resolution? So that will almost occupy your complete page, right? But if you want to show it in a smaller space, you can write it as width equal to 0.5 slash line width. So line width is basically the first margin on the left side and the right margin on the last margin on the right side. That is what is giving you the slash line width. Now 0.5 times the line width basically reduces the image to the half of the line width. Okay, so this is how you can increase or decrease the picture size. Alright, there are a few fancy things which you can play around with this. This command called slash centering makes your figure to appear in the center instead of appearing it on the left side or the right side. Okay, now there is one more thing called slash caption. All the figures need to have a caption, because otherwise how do one know what figure it is representing? So slash caption is basically to give a title to the figure. Now you see slash caption, I have written this is a coronavirus image. Now you see here figure 1 colon has automatically been placed by your LaTeX file, LaTeX tool, and the title has been copied. This is a coronavirus image. All right. The next thing is you can also label the image and refer this label in the text, something like this. Now the labeling can be done using a command called slash label, and in the curly bracket, now in the curly bracket this can be a user defined label, but it has to be unique. If you have 100 such images to be copy pasted in your document, you need to have 100 different unique labels. Okay, so always it is important to label these images very properly. Now for my reference, generally I have a habit of labeling all the figures using the extension called fig colon, and all the tables, if I want to label, I mark the label as tab colon. If I want to label the sections, I call it as se or something. Okay, so always have some notation with you so that you can follow it throughout the document. Now this is the label. Now if I want to mention in the text saying that the below figure 1 represents the image of the corona or something like that, this figure 1 I need to use it in the text. Now how do you use it? You just uh, use a command called /ref and copy paste this label here in the curly brackets. So it automatically, if this is the figure 2, here it will show figure 2. If this is figure 10, this will automatically show figure 10, and so on. So this is what is called as labeling, and this is what is called as reference. Is that clear? Okay, you can again possibly go to the document file, adding a figure, and copy paste this. Now before you actually copy paste this, you need to do one thing, is to create a folder in your working directory and add that particular folder path here. Only then it will work. And inside that folder, you need to have some image, XYZ image, and that XYZ name of that image has to appear here. So I give you like 2 minutes or 1 or 2 minutes. Possibly you can copy paste this code. Okay. Any doubts? Are you able to do it? Let me know if you're facing any problem. You just have to copy paste this code. Now before compiling this code, one caution is create a folder and add that folder name here and keep at least one image inside the folder, and that image name should appear here. That's it. Let me know if it's working. You can use the chat box. It is, you just have to create some folder like this, and inside this folder you can keep 1 or 2 images, possibly downloaded from Google or from your own. If you have some trip photo, you can keep it there, and then use the code. Anyone got it? Let me know who are trying in the chat box, or is it that simply I'm waiting for your response? Is anyone trying? Exceptions. Mm. Sir, you are getting exception. Can you quickly tell me like what kind of exception? You are using Windows or online overleaf? Corona file. Yeah, it says Corona file not found. So if you're getting exception, you should make sure that wherever your text file is there, in that folder itself, you have to create the folder for the images. If you are keeping this folder somewhere else, then the complete path has to be given. But then I avoid giving the complete path of the folder. Instead, what I do is I create the figure folder inside the folder which I'm working on. So it saves my time. So I hope anyone got the output. Okay, sir, you got it now. Okay, fine. All right, so we can go ahead. So this is about adding figure. Next is creating the list. Now, most of the reports will have some bullet point lists or the numbered list. Now, the reason why you have bullet points in the numbered list is to let you know the sequencing or the steps which is being followed for some XYZ algorithm or so on. Okay. So how do you create the list? There is something called as unordered list and the ordered list. Unordered list is what is called as these bullet point listing, and the ordered list is called as the numeric listing 1, 2, 3, or Roman 1, 2, 3, and all that. Okay, so an unordered list is can be obtained using slash begin itemize. This is a command. This is the environment which you have to use to create a list. Slash begin itemize slash end itemize. Okay, and for every item which you want to add, just say slash item and then start writing the item content. Similarly, if you see here in the itemized environment, I have written 3 items here, and in the output you see you have 3 bullet points generated with the respective contents at the bullet points. Now there is a small change which you can notice here, that by default the bullet points will be a black dot, but then you can change the style of the bullet. So as I've told that anything within the square bracket is the optional thing. So I have changed it using the optional thing, and I have put it as plus inside the bracket. So the black dot will now change to plus. Now, if you want to do a ordered list, you have to use an environment called enumerate slash begin enumerate slash end enumerate. Again, here same thing, slash item slash item slash item. You keep on entering the items. Okay. Now here one more thing, if you notice that by default the numbering will start from 1 and goes on incrementally by 1. But if you want to break the chain and say, let's say I want to give us some different number to the third item, you can write it in the square bracket. So that square bracket thing will appear here. Is that clear? It is very easy. You can quickly go and paste from this. Okay. Now one information, that it is all in the slash begin document and slash end document. Okay. So we are dealing only with the body part, but the preamble part has to be fixed. You cannot delete complete thing and paste here, paste this. So the preamble part has to be there. Okay. So I hope all of you are able to create this. Okay, going next is adding a math to a latex. Now this is very useful for people who are writing reports and probably the scientific papers. Now there are 2 different ways in which you can write the mathematical equation. The first, I'm going in a little at a little pace because we are left with only another half an hour. So there are 2 ways in which you can write the math equation. One mode, the first mode is called as the inline mode. The second mode is called as the display mode. Now inline mode is something like this. If you want to write a sentence, say the straight line equation is represented by y equals to mx plus c. Now this mathematical expression, if you want to keep it as a part of your statement, that is what is called as inline math equation. But if you want to display, if you want to represent a math equation as a separate line and display it in the file, that time you have to use a display mode. I will tell you how to use this. Now, inline mode is generally written inside the dollar sign. Okay, so whenever you start and end the dollar, the content between that will be treated as a math environment. Okay, for example, if I want to write x square, how do you write? You start and end the curly bracket, and inside this you write x hat 2. Now x hat is again a key on your keyboard. You press that and 2. Now whenever you say hat, this thing will go as a superscript to the variable x. Now for example, if you want to write x subscript y, so how do you write this? You again start and end a dollar sign, and inside that you write x underscore y. So y will automatically go below the xy. So this is how you write a superscript and subscript. Is that clear? Now just for your information, just for your copy pasting thing, you can refer to your document 2. And yeah, one more thing, you have to use a package called AMS math. Okay, so all the mathematical symbols which are specific to maths, for example, a real value, how do you write a real value? Like R double line and then R. So that is something like a special character R. So all those special math symbols are available in AMS math package. So remember to add this package in the preamble section. Okay, now you can copy paste this thing and then run it. Okay, one thing I forgot to mention, it's not just within the dollars. There are few more options by which you can write the inline math equation. The other way is slash common bracket and then slash closing bracket. Inside that, whatever you write, that becomes the inline mode for the math equation. The second way is between the dollar signs, which I have already explained here. And the third is between the environment called slash begin math slash end math. There are three ways in which you can represent the math equation in between the text. Now you see the output here. You see this, the math equation is E equals to mc square, which is being generated by the first method, or the math equation is E equals to mc square generated by the second method, comma, or the math equation is E equals to mc square generated by the third method. Okay, so you can use any of this for the inline text. Clear? Okay, coming to the display mode. Now, if you do not want to write the math equation as a part of the text, you can display it as a separate line. And there are options that you can either number those math equations or do not number those math equations. Okay. Now how do you actually write this? Okay. All right. Now there are again various ways in which you can do this. You can again go to the code and see. The first math equation you see in the output is being generated by slash begin display math slash end display math. So when you use this environment, it will give you a math equation in the separate line which is not numbered. Okay. Oh no, sorry. Yeah, the first equation is created using slash square bracket slash square bracket. If you use a common bracket, it is an inline mode. If you use a square bracket, it is the display mode. Okay. So in the display mode, this equation is not numbered because you have used slash square bracket slash square bracket. Similarly, there is another option, second option, which is a display math environment. Using this also, if you write the math equation, this will not be numbered. But if you want to number the particular equation, you have to use the environment called equation. This is slash begin equation slash end equation, and you write the equation inside this. Now, you see one more extra thing I have added in this code, that is called label. Now, if I want to refer this particular equation in the text, saying that uh, the line equation is shown in equation number 1. Okay, so how do you get that 1? That is basically a label. So I uniquely create a label, and inside the curly brackets I write some user defined label, and I think I have, yeah. So you can see here, but the next following math equation is numbered as equation and slash refer. So this is what is used for referencing the equation. Similarly, we have used it for figure referencing, right? So just copy paste this label inside the ref, and you see the output. This number 1 is automatically displayed. If you have, let's say, 100 equations in your report, you really do not have to worry about the numbering. The text file will automatically take care if you uniquely write a label for each and every equation. All right, I hope you have copy pasted from the document too. We will move on. That was something simple. Okay, now people, you might say, okay, this is no big deal, but if you look at this particular slide, you see that these two equations looks very complicated, but still we can be able to do it very easily. At first, the equation environment which you see might make you a little scary, but then it is very easy. Now you have this, I don't go into detail, but just to tell you, this T has some superscripts and some subscripts. Okay, so how do you start it? You write a T, and a hat indicates everything to be written as a superscript, and the content which has to go in the superscript, you start a curly bracket here and you end the curly bracket here. Okay, then next content is something which is subscript, so you start underscore, and all the contents uh, can you repeat this again, sir? Which one? The inline mode. It's okay. All right. So yeah, display. Okay, just to repeat quickly, display mode is to display a equation in a separate line. You can either number them or do not number them. If you want to number the equations, you have to use it in the equation environment. But otherwise, you can use a slash square bracket or a display math environment. Okay. Now this is again a label which is uniquely representing the equation, and the same label can be used in the text to call a reference number. Okay. Now you can see this. You can possibly copy paste the code if I have in the, I don't know if it's there. Display math. Okay, that complicated, but nevertheless you can do it. Okay, and you see fraction. How do you write a fraction? 1 by 2. You have a command called slash frac, curly bracket, curly bracket. The first curly bracket indicates the numerator part. The second curly bracket indicates the denominator part. Okay, and goes on and on and on. You can do this easily. Moving on to sections and chapters and sections. This is again very useful, because when you do it in the Word, you possibly hit with the different font sizes for all the different sections and subsections. So you have to every time go scroll 10 or 20 pages to up and down and then change the font. But then LaTeX does it very nicely. Now to organize a document, okay, there is a command to organize a document which vary depending on the document type, and the section numbering is automatic here. Now if I say, okay, the section numbers will be disabled by using a star symbol to the section. For example, slash star section star, and in curly brackets the title. Okay, let's look at the code. So slash document class book. Now please pay attention here, this is a book, not an article. So this is another type of a class which is available in LaTeX. Okay, and the second line is slash begin document, last line is slash end document. So this becomes the body of the report. Now you see slash chapter in curly brackets some text. So you see this chapter 1 automatically gets appeared in your report, and whatever you represent in the curly brackets, that becomes the title of the chapter. So it basically, you can just look at this code and realize yourself how easy it is for you to create all the headlines and sub headlines without worrying about the fonts. Okay, now similarly this is a chapter. Now in a similar way you can create a section. Now section is something like one in the chapters. If you want to create a section, it will be like 1.1, 1.2 and so on. So section, you just start with slash section in curly brackets, give the title, and you see in the report 1.1 is automatically generated, and the title of the section is into, oh sorry, yeah, the first is introduction is here, this is introduction, then this second section is here, this is being generated here, and if you want to create a subsection, that means 1.2.1, then there is a command called subsection. If you want to create subsection, you can say slash subsection curly bracket, give the title. So you do not really have to worry about the font and the indexing or indenting and all. So it automatically takes care. But if at all you do not want to number any section, as I said, you keep a star. Okay, so slash section star and then curly brackets. So you see this unnumbered section is not really numbered, but if at all it has to number, it will be numbered as 1.3. Okay, so you can copy paste the code and then run it. All right, next, again very important thing is to create a table. So here there is an environment available in LaTeX called tabular. Okay, and this is a default LaTeX method to create a table, and there is no preamble part required for this. You can directly start with slash begin tabular slash end tabular. Okay, now the reason why I have included this extra thing slash begin center and slash end center is to make this table appear at the center of the page. Okay, otherwise all these figures of the tables, if they are not centered, the report looks ugly. Okay, so always make a habit to keep it at the center. Now there is one extra parameter which you have to mention for creating a table, that is again written inside the curly brackets. Now you see that you have these letters called C. C means center. If I have here the letters as L, that means it is left aligned. If I have the letter called R, that means it is right aligned. So you have only three options here: L for left, C for center, and R for right. Okay. Now these vertical lines which you see neighboring to the C is basically used for drawing the lines in your table. You see before the, so C is basically replaced by the contents in the table. So you see 1C, 2C and 3C. I'm basically creating a table with 3 columns, and the text of all the 3 columns will be center aligned. You see this is first column, second column and third column. And these lines, the vertical lines, are basically used to create a margin lines for the table. Okay. And how do you enter the fields inside the table? Now since you have 3 columns here, you write each row one by one, and all of the rows are separated by double slash at the end. It is very important, otherwise it throws an error. So the first row I enter it as cell 1. The second entry in the table is separated by and, then cell 2 and cell 3. Okay. Now for example, if you do not want cell 3 content, you just want cell 1 and cell 2. So it is obvious to skip this second ampersand, right? But if you do so, it will throw an error. Even if you do not have any content, you have to have the ampersand symbol in the text or in the LaTeX code. Okay, and each of these rows should and must end with double slash. Okay, it is not necessary for the last row because after that there are no entries. Okay, so I hope this is clear to you. You can again copy paste the code from the uh, yes. So this is the code which you can use to run the table. Now the next part, table 2. Now in the table 1, you just had created some cells and did some entry. But if I want to do some fancy thing like captioning the label, giving a title to the label, and referring that label in the text, so you have to use something called as table environment. Now, table environment always begins with slash begin table slash end table. Okay. Now, this square bracket after the table indicates that when this particular text gets over, since after that particular text I have written a table environment, it has to appear here itself. So H means here, T means top, B means bottom. So these are the three different variations which are available with this. And this exclamation mark is that it is kind of a forcing the table to appear after the table itself. Okay. But generally, if you see the standard textbooks, all the tables or the figures, either they will be on the top of the page or bottom of the page. Okay. So this is not compulsory, this is optional. In case if you want your table to appear after the text, you just mention here and exclamation mark is compulsory. So H means here, compulsory. And slash centering is to make the table center, slash caption is to give the caption to the table, slash label is to give the label to the table. Now this is again called as the preamble of the table environment. Okay. Then after that, your actual table will start, which is again the same thing which we have mentioned earlier. Now, if I want to represent this table one, the one numeric one into your text. Now, how do you do this? Again, use a slash ref command and copy paste that particular label here. Now, if your report has 10 to 20 different tables, all the table labels can be represented uniquely and referred uniquely. Okay. You can again copy paste. Yes, creating a table with caption. The 10th thing, you can copy paste this and see the effect. Okay. Now, next thing is to add the table of content. This is what is called as the index sheet of the report. Now, how do you create the index sheet of the report? It is just a single line. Okay. If you were to do it in the MS Word, you really need to break your head because all these dot lines and the page numberings and the title and the subtitle, its font, it is very hectic. So what we can do is just add one single line in the body of the document. The command is slash table of contents. Okay, that's it. The content will automatically be created with proper chapter numbers like 1 and 2, 1.1 and the respective page numbers. Okay, so it is very simple. I hope this is available in the document. Yes, so you can possibly copy this thing. You see that there is only one command which is slash table of content. Okay, so did we do this make table, sorry, make title? I think no, right? So make title is basically to create a title, and if you refer my slide here, there is something called as slash title, slash author, slash date. If you want to represent all of these three contents, you have to use a command called slash make title. So this automatically generates a file with the title for the report. Okay, but without the slash make title, these things will not appear. I am sorry that I forgot. I think I have mentioned these commands in the first slide, but I forgot to mention slash make title. So slash make title is to create a title. Slash table of contents is used to create the TOC for your table of content for your report. Okay. Moving on, this is again a very critical part for creating your report, because all the work which we do is by referring to some of the journal papers and conference papers, and it is not a good practice if you do not cite them. So for any citation of any existing work by any author, you need to create some kind of a bibliography or reference. Now this is little just like the way we did for figures, it needs little workaround. Now the first thing which you need to do is to create a file inside your working folder with the extension called .bib. Is that clear? I'll go back to my folder. Now, okay, I think it does not have. Okay, so let's say this is my working folder and this is the file. Is that clear? Now this file name has an extension called .bib. It is called as a bib file. This you are creating it, okay? And what should be the content inside the bib file? I'll just open this, double click and open. Okay, so these are the contents of my bib file. Now from where did I get this information? These are nothing but some papers which were published by some author and in some conference in some year. So all of this information, from where do I collect it? By manually typing it, it's really tough. So what I do is, there are so many resources to get the papers which you refer. Either you go to Google Scholar, or you go to IEEE Explore, or you go to Sci-Hub, any of these websites, and even more. So wherever you are referring any of the journal papers, you go to any of these and type in your title, the title of the paper which you are searching. Now once the paper appears, this figure is generally shown only for the Google Scholar, but you can try it for Explorer, IEEE Explorer and Sci-Hub. So in the Google Scholar, if you type a title of the paper like this, it pops up like this, and you click on this double comma or the colon, it shows you a window like this. Then you click on BibTeX. When you click on the BibTeX, it shows you the content of the BibTeX like this for this particular respective paper. Now what are the contents in this? It says the title equals to something, authors equals to something, book titles equals to something, page equals to something, year equals to something, organization equal to something. Okay, so all of these contents are automatically being provided by your Google Scholar. Just copy this and paste it in your bib file. If you have 10 references, collect all the 10 BibTeX of the papers and paste it here. Now one thing you have to notice, all of the BibTeX will have a unique code for it. For example, the first paper is Balure 2016 depth. Next is Balure 2017 GMM. Likewise, if you have 100 papers, all those 100 papers will have different unique name. Okay. All right. I'll close this. Now, once you have collected all of this bib, now your bib file is ready. Okay. Now, how to use this bib file to show a reference section in your report? Now, this is what it is. There is a command called /bibliography style. There is another command called /bibliography. Now, these two commands are required for you to show the BibTeX of the reference papers of journals into your report. Okay. Now, what is this /bibliography style? It is basically the style in which your references needs to be appear. Sometimes they will be numbered as numeric, like 1 or 2. Sometimes there is a different style called author, year style. So that has a different style name. I think it is alpha. If you copy paste the alpha here instead of abbreviation ABBRV, you get the author and the year. And there are so many other options in which you can try and play around with this. So this is nothing but the style. And second command /bibliography, inside this curly bracket, you need to mention the bib file. You remember you have just created a bib file with all the BibTeX collected from the internet. So the file name of that particular thing has to appear here. Okay. Now, how do you actually represent those references in the reference section? Is by citing the particular paper. Now, let's say this is a text which you have. Sorry. Let's say this is a text which you have, and in the text I say you read the output here. This is introduction, this is introduction. The first paper is square bracket 1 and the second paper is square bracket 2. So this means 1 means I am referring to 1 and 2 means I am referring to 2. Now how did you get this automatically? So you see here I have used command called /cite, and this is a unique name of the BibTeX which uh, I have copy pasted in my BibTeX file. Similarly, Balure 2017 GMM is again the unique name or the unique code for the second paper. Similarly, you can have 100 papers and 100 different unique names. You can just copy paste those and generate it. Now, very important is at what location you need to paste or at what location you need to cite. It depends on user to user. If let's say you are mentioning 2-3 different papers at a time, you can just say paper 1 comma paper 2 comma paper 3. So it will show all the numeric references 1, 2 and 3 side by side. Okay, all right. So this is the way by which you can get the bibliography automatically, and there is one more way by which you can manually create the bibliography. That is by using the environment called /begin b bibliography. But then the hectic of this is that you need to enter all the fields. Now, what are the fields? If you remember the BibTeX, there was title, there was author, there was year, there was publication, there was page number, and so on. So all of those entries you have to manually create by using the command called /bibitem. And inside this curly brackets, this is again a unique name for that particular bib item. You can have 10 such bib items representing 10 such conference papers, and each of them should have a unique bib item name. Okay, and how do you refer this? It is again the same. Use /cite in your LaTeX file, and you see the output here. It automatically displays a 1. Okay, possibly in the first compilation it might not show, so you can just run 2 or 3 times to show these numbers. Okay, so that's all. So we have seen most of the things which are required for report making. Let's quickly, we have time, give me. Okay, so what we can do is we can in another 5 minutes we will see a few examples of how to create a project report, how to create a conference template paper, and let's say a journal paper. Okay, so to create a project report, you definitely cannot do a runtime. Just listen to me the way it is shown on my screen. Okay, so it helps in preparing the reports, articles, books, and many more. And the default, there are so many default class templates which are available in LaTeX. For example, article, for example, book, for example, report. But uh, the the example which I'll be showing here is for the preparation of article. Okay. For example, in the folder which you see here, you need to create a folder something like this. You need to, sorry, you need to have a folder which has all the figures related to the report. You need to have a bib file which will have all the bibtex of the papers which you have referred, and the main file. Okay, this is the main.tex file. Please note the extension. This is .tex, this is .bib. So only these things are required for you to write the report. Now in this tex file, I will quickly show this. This is a main.tex file, this is a bib file, and this is the folder in which I have kept all my images. I'll open this tex file. Yes, so you see this main.tex file. Okay, now I have an article here, and in the square bracket I have optional arguments like A4 paper. That means your contents in the document will be printed in the A4 format, and the font of most of the contents will be 12 points. And these are some packages which I have included. Possibly you can check out. This is the path of the figure where I have kept all the figures. And okay, so this portion is called as preamble. Correct. After preamble, you start with slash begin document. Okay, and then go on. All of these are contents which you can refer. Probably I can share this with you. And then there's a command called double spacing which I have used because all the reports needs to be 1.5 spacing. Oh, it's not double spacing. It should be 1.5 spacing, or double spacing also is fine. For reviewing the reports, it should be in the double spacing. So so this is what I just run this and show you. See this. You see how beautifully it has created. You have the title, some synopsis, this thing submitted by guide name, logo, department, and then you have a declaration with each of these lines separated by double spacing. You see the justification properly. There is no left or right alignment. You have certificate generated. You have table of content nicely generated with page numbers. You have properly titled sections and all of this. Okay. You see here in the reference section, I have reference 1, reference 2, then you have math equations which are numbered. This is again math equation which is running over multiple lines but numbered only once. You can, I'll share you the text file of this. You can refer the code, and there is a way in which you can add the algorithm, something like this. There is a figure which you can add like this. There are options that you can add figures side by side also. So this is sub figure 1, this is sub figure 2, but you have a common title, something like this. There are options where you can merge the rows and the columns of the table. So these are few examples which I have shown. Then you have conclusions with bullet points. Then you have future work with numbered list, and then finally references. Okay. Now this looks very simple, right? But then it really needs some kind of a coding. It's not really coding. We don't call it as a coding, but yes, it definitely needs some commands to execute this. Okay. Now quickly, what I'll show is, as I've earlier told in my first slide, that LaTeX is mainly keeping you or making you to think only about the document content. It keeps you away from the typesetting formats. Okay. So what I do is I just copy paste only the content. That means only the body part of this report. I do not take all the preamble. I just take the body part of this report and copy paste in the IEEE format. Let's see how easy it is. I will open an IEEE example. Okay, I'll go back to my slide quickly. So to create a report, it is done. Now to create any kind of a write up, any kind of a conference paper, you need a template file. Okay, so you can possibly go to this IEEE website. You can download the template. There is a zip file which is available, and there are few instructions if you want to read. So in your folder, you need few things. One is the class file, okay, and the other one is the BST file. I'll show you where it is. Now this is a link where you can access, download the templates, and this is the location where you can download the templates. And once you download, you get these files. Okay. Now I have to copy only the CLS file and the BST file from those downloaded things and put it in my working folder. I'll show you my working folder. This is my working folder. I double click. Okay. Now you see .cls file and .bst file I have extracted from these downloaded things. So this is the downloaded folder. I go inside, I extract the BST file, and I go to this and I extract, where is this, class. So this .cls file and .bst file, both of these I have copy pasted in my working folder. Clear? Now, as usual, your main text file is this, your bib file is this, and the folder containing the image is this. Now, I run this particular code, or basically open this. So this is how it is. Do not worry about this for the time being. Do not worry about this also for the time being. Uh, just see this. Okay, so I have just copy pasted all of this introduction, literature, methods, method 1, method 2, algorithm, results, everything from uh, the report which I have created earlier. Okay, and when I just copy paste in the IEEE format, I run this file. Yes, see this. How easy it is for you to convert the report from one format to the other format. Okay, this is the beauty of LaTeX. So you can have an appropriate title, author. It is a double column IEEE format. So if you are writing since it is compulsory for all the BTech final years to publish a paper, so you can use this format to create your. See, all of the contents are same. It's just that I have changed the formatting, and which decides the formatting? It is this. Okay, remember earlier we have used article, but now IEEE tran is nothing but a class file which is available in your folder. Similarly, a BST file is nothing but for your BibTeX information. Okay, likewise I have created same content has been copy pasted. Okay, likewise I have another journal paper like Springer journal paper you can refer, or Elsevier, Taylor Francis, InterScience, there are so many. So each of these journal publisher will provide you with the own LaTeX template. So what you have to do is just extract .cls file and .bst file. I go to my working folder and show you. So you see .cls file. This is basically containing all the information regarding typesetting, and these are three different BST files. You can use any one of them. Okay, and this is my main text file. You see some of the auxiliary files which gets created along with the PDF, but you can ignore them. And there is a bib file which I have created. There is a folder for the images. I double click this, open it, just copy the content of the report and change only the class here. You see this is a class .cls file, and then run it. Wait for a moment and you get a content which is being prepared in the Springer format. Okay, so this is how easy it is. I hope this workshop might have helped you in some way, and let's see, if you have any doubts, probably you can come back to me later. Okay, and with this, yes. So with this, I think I'm done with it. There are a few references which you can definitely use it if you are starting new. There is a spoken tutorial by IIT Bombay which tells you about the basics of TechWorks. There is a whole lot of, okay, this red thing, this margin, this gray shade, all this bottom line thing. If you think how it is created, this presentation is again created using LaTeX. So all of these fancy styles are available online. You can use any one of them. Okay. Now you can go to this website to see all the math symbols. You can go to this website to generate automatic code for the table, because creating a table is a little complicated for newcomers. So you can go to this website, just feed in the table content and generate the table code and copy paste in your text file. Okay. So with this, I'm done. If you have any doubts, you can post it. Me? Okay. You can, those who are outside the department, you can, Okay, so you can send an email with your queries. Any doubts? Any quick doubts? I can take another 5 minutes before the college closes. Okay, so I think with this we can stop here, and thank you for your participation. Yeah, yeah, we will send a feedback link probably in 5 minutes to your mails. You can all give your feedbacks for better improvement or any suggestions. Take care. Huh?
Chandra sir, thank you, sir. It was nice, sir. Thank you so much for your efforts. Hello, Chandrasekhar, sir.
Yes, sir.
Yeah, it was nice, sir. Excellent, sir. Thank you for your efforts and putting efforts for delivering such a good lecture on LaTeX. A lot of us
Thank you.
got benefited and it was excellent,
Yes,
sir. Thank you, sir.
yes. Thank you so much, sir. It's all
Welcome.
your support that we are doing this, sir.
And no, sir, it's
Yes.
your knowledge that you're sharing it, sir. That's a big thing. That's very great thing, sir.
Thank you
Because
so
now
much,
we
sir.
came to know how the Springer and IEEE people also can be written using that.
Yes, sir.
Thank you very much, sir.
Thank you so much, sir.